about transformations of function. We're on 1.4. So a parent function, that's just a little vocabulary word you need to know. It's the simplest function before any transformations have taken place. So it's just the original function. Nothing has changed here. And we're going to talk about 4 different ones, and these 4 you need to get used to knowing what the shape of the graph looks like. So when I say linear, you need to picture a straight line in your mind. So a linear function is f of x equals x. That's just the original before any transformations. And we're going to graph those. And I'm going to show you how to do this in your calculator. If you want to write down the calculator steps, you can. We're first going to type that into y equals. So go to y equals. Now, if any of these at the top are highlighted, like all 3 of mine are, we need to turn those off. So I'll take my cursor up there and hit enter, any of them that are in black. And then if you have anything else, like there's a random 8 down there, I need to clear that out. Okay. And this one is just equals, remember f of x is the same thing as y. So this is really just y equals x. And I type that in. Now I'm not going to go to the graph because I actually want to look at the table of points. That's going to make it easier for me to draw it. So you're going to click second graph. The second button makes it go to the table instead of the actual graph. So second graph, and it takes you to a table. These are all of the points, and you can scroll up or down like forever. If yours starts at like 100 or something, let me know, and I'll fix it so that it'll just automatically go to a smaller number. Okay, but if I look, I mean, again, I can go up, down forever. Some of these numbers, they start getting really big. The graph that I have given you, what's the biggest number I can go to? What? 5. If I want to graph on this picture, the biggest one I can do is 5. So I'm not going to write down any of these numbers that are bigger than 5. So, and I only left 5 spots in the table, so I don't know, -3, -3. I just ran up, that's just the one I picked to start. No particular reason. I knew it can fit on my graph. -2, -2, -1, -1, 0, 0, 1, 1. And I'm going to plot all of those points. So that is an original linear function, a graph of that. I've not, transformations mean like I move them, I rotate them, all of those things. I've not done any of that. This is just the original. That's the parent function. The next one is a quadratic. Its equation is f of x equals x squared. So I'm going to go back to my y equals, and I'm going to change this to x squared. And then I'm going to go to my table, second graph. And yeah, those, I can't, like this first one that mine shows up on is negative 864. I can't plot that on my graph. I don't have enough spaces. So I'm going to go down to the numbers that I can, which are negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And I'm going to graph this. And when you connect those, it ends up making this U shape. Quadratics that is not a sharp point at the bottom. It's more of a curve there at the bottom. So don't draw a sharp point because that one's actually absolute value. So it's more of a U shape. We will spend a whole unit talking about these. And it's like 5 weeks long. That's after Christmas break. So what I want you to get to is when you see an x squared, that's a quadratic, it's a U shape. Absolute value, that's f of x equals the absolute value of x. Those vertical bars are absolute value. Does anybody remember how to get those bars on your calculator?
It's second or right equals, I don't remember which one in that window.
It's actually alpha window. Yep. You would have got there eventually. Alpha window. And it's the first one, ABS, absolute value.
Right.
X. Now, you all know if you just hit this button right here, that'll type in an X. Or you can click alpha and then go down here and find the X. Either one. But this one's faster. That button. Second graph is going to take me to my table. Again, I'm gonna start with negative 2. You could have started with negative 3, but I'll show you why in just a minute. Negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. A function that's absolute value makes this V shape as a sharp point. Okay. And then the last one we're going to look at is a square root function. F of x equals the square root of x.
Teachers, pardon this interruption. I need the following people.
So back in my y equals the square root, you have to hit the second button, and then if you go down here, that x squared button, the square root of x. So a square root function has a square root symbol in it. And then I hit second graph. Alright, I see a whole bunch of errors. We'll learn about why you're getting errors like in the quadratics unit. But it's because you can't take the square root of a negative.
So like the positive error, just like those.
We won't use those. So, and you see how some of these are decimals? Those are going to be really hard to like get in our graph. So let's just pick out ones that have whole numbers. 0, 0, 1, 1, 4, 2. And those are the only ones that are going to fit. Oops. Yeah, I mean, you could put the decimals, but these boxes are so tiny, you don't need to do that. That's what a square root function looks like. It's just like a fancy, weird curve thing that goes to the side. So, if I say quadratic, U shape. Absolute value is V shape. Square root does that. And linear is a straight line. So what we're really getting into today are translations. Now, we are not going to talk about rotations, reflections. The only one we're going to talk about in this unit are translations. Those are the easiest ones.
Bailey Terry to the front office. Bailey.
So we're only doing these. So translations means
Addie King to the front office. Addie King.
Means that I can take one of these graphs and move it left, right, up, or down. And the way that I put that in the equation, I'm going to add or subtract certain numbers in certain places. So for example, this is the fancy notation. What you need to know is that if I am adding on the inside, well, I wrote that too big. Hold on. Add on the inside, it's going to move left. So add inside moves left. So for example, if I have a square root function, and on the inside, originally, I just have x. But if I make it a +1 on the inside, an x plus 1, that's going to take my square root function, this graph, and move it to the left 1 point. So I'm just going to put L1. It moves left 1. So that's a square root function that moves left 1. So all of these points would just be shifted 1 to the left. If I could type that in y equals, I could do the same thing and see that it went to the left 1. Okay. Now this one is taking the x and I'm subtracting, it's inside. The notation shows that it's inside the parentheses. So if I subtract, and I'm just going to put SUB, subtract inside, that one moves right. Using the same example, if I had put the square root of x minus 1, that would be going to the right 1. The minus on the inside moves right, and it's minus 1. So this one, if I put it in the y equals and look at the graph, would go this way. Each point would move that way. These I'm adding on the outside. So if we add outside, this one moves left. No, sorry, moves up. Moves up. So the square root of x, if I have a +1 and that's outside of my square root symbol, it's going to go up 1. And then the last one, if you subtract on the outside, it moves down. So for example, the square root of x, if that minus 1 is on the outside, that's down 1. We're going to do just a few examples. So we're going to name what type of function it is. If it has an x squared, it's quadratic. If it has absolute value bars, it's an absolute value function. If it has a square root symbol, it's a square root function. And then we're going to tell if it goes left, right, up, or down, and how many. So number 1, what type of function do you think it is? Those 4 in the front, the first page. Linear, quadratic, absolute value, square root. What?
Square root.
Do you see a square root symbol?
Right.
It's a quadratic. If it has a squared, an exponent of 2, it's quadratic. Now this really was not a good example to start with. I wish I hadn't put this one first. On a quadratic, if something is on the inside, you will have parentheses. So in this case, that plus 1 would be on the inside. Is this minus 1 inside of parentheses here? No. So we can assume it's on the outside. Do you have anything inside of parentheses? On number 1, like this x squared minus 1. Is there anything with the x inside of parentheses like this? No. So it does not move left or right any. It has a minus 1 that's on the outside. What does a minus on the outside do?
Go down.
It goes down. So this one would be down 1. Number 2, what type of function do you think it is? Linear, quadratic, absolute value, square root. What? Quadratic. If you see an exponent of 2 squared, you're going to have a quadratic. Does it have anything added or subtracted inside of the parentheses? Yep. What's it got? It's got a minus 2. What does subtracting on the inside do? Moves right. Yep. Subtracting on the inside moves right. So it would be right 2. The inside is opposite. You think minus moves left. That makes sense. But when it's inside, everything is the opposite. So it moves right 2. And then it has a minus 1 on the outside. So that's going to be what? Down 1. Good. Number 3. What type of function do we have? You see those vertical bars? That's absolute value. It has a plus 3 on the inside. So when you have absolute value bars, if it's between the 2 bars, that's considered inside. What does a plus 3 on the inside make it move? Left 3. Okay. And then this one also has a minus 1 at the end. What does a subtracting on the outside do? Down 1. I want you to do number 4, and then I'm going to call on somebody. What type of function is it, Patience? It's absolute value. If you see those vertical bars, it's absolute value. And Andrew, how does it move?
Right.
Right 2. Does it go up or down any? Nope, because there's no numbers added or subtracted to the end. Okay. Number 5. What type of function do you all think this one is?
Well,
It's a square root function. Good. In a square root function, if it's considered inside, it's going to be underneath the square root symbol. It'll have to have that little bar going across it. Does that -4 look like it's inside of the square root? No. So we don't have anything on the inside. We only have something on the outside. We have a -4 on the outside. So Lincoln, what does a -4 on the outside do?
Down 1.
Goes down,
4.
down 4, yep. Down, and then because it's -4, it's down 4. Try number 6. All right, Braden, what type of function is this?
Square root.
Square root, perfect. Ella, what's one way that it moves? What?
No, right. Left 3.
Left 3. The plus adding on the inside moves it left, and it's left 3. And McKaylee, what's the other one?
Right 4.
That -4 is, look at subtracting outside.
Down 4.
Down 4. Good job. No, you're good. All right, there's 2 more questions, 7 and 8. I want you to work on those 2. All right, I'm going to go over these really quick. Number 7 has the squared. That's what makes it a quadratic. It has a +5 on the inside. Adding on the inside moves left. There's nothing on the outside, so it doesn't move up or down. Number 8 is a square root function because it has a square root symbol. It has a -9 on the inside. When you subtract on the inside, that moves right. So right 9.